We will define or describe geographic information system from the perspective on how it can help us, what it can do for us. Geographic information system is first of all a kind of information system, which means it can do the job as storage and retrieval analysis of data. But in this case, it will have special functions for handling geographical data. One of the unique and distinguishing characteristics of GIS is advanced spatial analytical tools that are usually built in. We're going to explore some of the tools in this class. The unique insight into spatial relationship and patterns and processes, and the way that GIS can integrate both human, cultural, and physical, and biological, and other phenomena in one spatial framework is extremely powerful. Well, the power of GIS really from the combination of three functionality of the system. One is mapping and presentation capability, where it's organized data into themes, and themes can be freely composed into maps. Okay. So that's normally done within the component we call ArcMap. Okay. Our first lab will deal with ArcMap. In ArcGIS, the management of spatial data is normally done inside another tool called ArcCatalog. On the bottom of the slides, you see a window opened up which shows directory and folders. Each folder you may have many different data sets, where each data set can be explored or previewed on the right panel, and you can actually see the content or metadata both in terms of geography and non-geographic attributes. So this is very similar to the file manager like a Windows Explorer, but it has a spatial function of managing spatial data. The third unique function group for GIS is the analytical capability. In ArcGIS, all the analytical and processing functions are organized into what we call ArcToolbox. Okay. This toolbox is very powerful. It includes both the normal use of data management, data analysis, conversion, and transformation, and coding, etc., analytical functions, 3D, three-dimensional analysis, and spatial and network analysis. These are the kind of add-ons to the basic function. Unlike a paper map, where we are limited to one or two or three, a few scales, in digital map we are open to explore the data in many scales, because we can zoom in, zoom out, infinite granularity to see details of the feature to the locality, or we can zoom out to see the global pattern of the things on a larger range. So this kind of capability is very important. We will show that many of the pattern only shows in one scale. They do not show on other scale. Okay? So we call it scale-dependent geographical patterns. To study this, we have to understand the concept of scale. Map scale is a representation of how detailed or how zoomed in a map is. In numerical term, it is a ratio number. In this case, if you look at this particular map on the top near the toolbar, there's a scale called 1/32 million something. Okay? So this scale number represent the fact that one unit on the map represent the 32 millions of the same units that can be measured on the Earth's surface. Okay, so it is the the correspondence between the reality and the representation on the map. Okay? When you talk about scale, make sure the unit is the same. Okay? The other common issue of talking about scale is that a common sense way to talk about scale is exactly the opposite of the scientific representation. Okay? So if we talk about a large scale map, when we talk about large scale map, is actually a map that is zoomed in, and a small scale map is a map that's zoomed out. Okay, so a map of the whole world is a much smaller scale compared to a map of the United States. In other words, a large scale map will show more detail, but in the same area of the screen, you're going to see less extent of the geographical scope. Compare this map with the map on the next slide. So is this map a small scale map or larger scale map compared to the earlier ones? Think about it. So this is actually a larger scale map because we see smaller extent of the Earth's surface, but we have more detail to look at. All the things we see is bigger size. Okay? A geographic information system has many important applications, including both the government, business, studies of natural environment, as well as social problems, okay, transportation, all use a very significant part of the geographic information systems. Indicate how widely it's used. Okay. Normally, the first step we deal with this kind of analysis is to map out where things are, okay, in terms of the location and patterns. Okay. If we map out where things are, most likely the human can pick up, can perceive the pattern, and can come up with some best guess, knowledgeable guess of how things are related. Okay? The powerful feature for GIS to show the pattern, not only to look at the location, but also you can link the attributes, the characteristics of the features with the location, and we can interactively explore them. We can also analyze the data by selecting the features of our interest. For example, we may be interested only on schools that has a larger enrollment of 1,000 or more. In this case, we can do a selection by attributes of the schools and specify SQL query criteria, and then the selected schools will be highlighted on the map. In order to understand the impact of the pollution company to schools, in this case we are interested only in the schools that are nearby or close in the proximity of those pollution area or pollution points. So one of the functions that GIS can support is proximity selection, where we can indicate how much distance band that could be used to select other features. Proximity selection can be accomplished by using the select by location function, as the dialog is shown on the left side of the slide, where you indicate where what are the layers you want to select the features from, and then you can indicate a source layer where it is the reference. Okay, and then we can indicate the target layer features must be within certain distance to the source feature layer. For example, if we are interested in understanding the pollution company's impact on the rivers and streams, we could look at the streams and river feature and then try to select all these pollution companies that are nearby to the streams. By doing a select by location, we're going to specify the target layer as the pollution company and the source layer as lakes and rivers. Okay? With a distance of a quarter mile, we can actually find out that there's a few pollution company actually very much near the streams. GIS is most recognized by two kind of advanced analysis on spatial data. One is based on the buffer zone analysis, which is very often being used for study spatial impact, spatial influence, marketing areas, such kind of phenomena. On the map shown, we made a 2-mile buffer zone around the pollution company, and we actually overlay that visually on the school's location, and we can immediately see those schools fall in this 2-mile buffer will be likely being influenced by the pollution. Next, I would like you to work on the first worksheets which covers the chapter 2, 3, and 4 of the ArcGIS tutorial. Okay. Before that, I'd like to briefly mention that ArcMap system strictly follow the graphical user interface design, and it has several panels of functions. Okay. On the top, we see regular menus, and we're going to look into the menus and functions incrementally. Okay. But in general, there's two major areas you call workspace. On the left, we have a table of contents where you will see all the kind of layers that has been added to the map. Okay, the layers are in the order that the bottom of the layer will be drawn first, and then the layer on the top of the table of contents will draw the last. Okay, so there's always a tendency of the top layer will cover up the layers at the bottom. Be careful on that. We're going to see how that could happen and how to deal with that. Okay. We also frequently have to deal with different tools for navigation, for the functions that are not in the toolbar. So we need to look at some general tools like identify, zoom in, zoom out, zoom to full extent, and those are commonly used tools. Okay. We also have the map documents where it shows the general extent of the map data. Okay. Anything you see on the map, we can actually use the tools with the little eye icon to identify. Means we ask questions like, what is this? Okay. When you do that, it will open up a window that shows the attributes of that feature. Okay. Particularly, we often use that function to find out what is the name of the feature, what is the kind of a population of a county or state. Okay. So that's the very popular use of interface feature on ArcMap.